a research on to try to find a disqualifying argument of what I'm trying to understand. So, for instance, I ran across somebody that I've never heard of in researching, and it's Georgia Sagnac, which in turn there was a big controversy about how he was trying to disprove Einstein. So, I mean,
no, there is no controversy there. There's only controversy in understanding what Sagnac did. Sagnac can totally be explained by Einstein's special relativity theory.
Oh, shit. Please.
not 100%.
Out of here.
Yes, 100%. Yes, 100%.
The
There's a lot
Sagnac
of misunderstanding going that's surrounding Michelson
Right.
Morley and Sagnac. You always hear people in the flat earth side talking about Michelson Morley was trying to detect the motion of the earth and failed to do so. It had nothing to do with that. Michelson Morley,
really?
Arwin
That was
Shaw.
the center of the
Michelson
experiment.
Morley
That was the whole reason why he did that.
No, it
Michelson
wasn't.
Morley experiment used
Wrong,
the motion
Arwen.
of the Earth as an integral part of the design of the experiment. It was
Arwen,
not
did you even read the report?
motion of the Earth. It was using the motion of the Earth to help ascertain whether or not there was ether drain.
Yeah,
Yeah,
people already knew. Go
Did
ahead.
you read the report,
It's using the motion of
Arwen?
What report?
I guess you're missing
When you do an
my
experiment, you write a paper explaining the experiment, your methods, what you did, all your
Yes.
results. Did you read it?
I didn't read it thoroughly, but I looked through it just like everybody else when they presented it.
Yeah, and nowhere in that report did they say that the Earth was not moving.
so
The entire point
what I
was
got.
Oh, really?
What I
So
got
you have
from-
to, everywhere you have to say what's not going on, right? Hmm.
You're
Yeah,
saying that was the result, correct?
No.
So
They
Then what are you?
I
What are
get
you
back
saying?
to my
The
point,
result
George.
was
So
that
the
the
experiment,
light
the Michelson Morley
moving.
experiment, the Michelson Morley experiment needed the velocity of the Earth of 18.5 miles per second in its orbit about the sun in order to have a sufficient shift of the interference pattern to detect whether or not there was ether drain. They
We
needed
can't
that
hear you,
velocity. They needed the motion of the Earth in its orbit in order for the experiment to work or not work.
That's right, George.
but
Motion
that
of-
wasn't
the motion of the Earth was a given.
point. That wasn't my point. my point was that everything Einstein's correct. I'm not saying that he's not correct. My point was that Sagnac pointed out that the fact that you're restricted to the position of your observation. So, and that is the only
Now, what does that mean?
point that has
don't
truly pointed out. What does that?
No,
What does that mean?
That's not what Sagnac.
That means that
No, that's not what Sagnac experiment revealed at all. What do you mean by? I don't even think you know what you're talking about.
okay. So the position of the observer is not a critical issue. Is what
Well,
you're
it is.
saying.
That's what Einstein's special relativity theory is all about. Everything is relative. There's only two things that postulates that Einstein proposed that resulted in the special relativity theory. One is that the laws of physics are the same in all inertial reference frames, and that the velocity of light is the same in all inertial reference frames. From that, the whole theory of the special theory of relativity was built upon. Everything is observation dependent.
Subject to interpretation.
No, not really.
No.
Einstein's special relativity theory is probably one of the most verified theories in physics.
Yeah, verified with things like light bending around the plasma limb of the sun.
No, that's general
like
relativity.
mu meson decay coming into the atmosphere to demonstrate time dilation and length contraction. We have many
Atomic
experiments.
clocks on airplanes. Remember that when they took atomic clocks and put them on airplanes and then compared them to static atomic
Well,
clocks on the
that
ground?
was more a verification of general relativity than special relativity. But yeah, it's along the same order.
Well, it shows time dilation though, doesn't it?
Well, no, not directly. In taking atomic clocks that are orbiting about the Earth, you're accelerating them. And in special relativity, accelerations are not allowed. You can only have inertial reference frames, which are reference frames
so
moving relative
the
to one
atomic
another
clock,
that aren't accelerated. Whereas when you take an atomic clock and orbit it, you're subjecting it to an acceleration, and the general relativity is telling you that frames that an accelerated frame is indistinguishable from a frame that's subject to a gravitational field, that accelerations and gravity are indistinguishable.
I see what you're saying.
Yeah, it's one of the
yeah,
problems.
but an atomic clock that's brought up to the highest point on Earth, and an atomic clock that's on land on the lowest sea level point of Earth, there is a time dilation there.
Yes. But
So
the Earth, there is an acceleration due to the fact that the Earth is rotating. You're in a rotating reference frame, which whenever you have a rotating reference frame, you're being accelerated. Ever so slightly that we don't feel it, but the acceleration is there.
Right. The further up you go, the faster your rotation.
Correct.
Or-
So in all practical purposes, yeah, what you're talking about, taking to the top of the mountain versus
so doesn't that go
down
back
at sea
to
level
doesn't that go back to Sagnac?
Hey, quit
Basically,
interrupting,
some of
will you?
Sagnac stuff.
People don't interrupt you.
If
Please
you're
don't
agreeing with
interrupt
each other,
us.
it gets annoying interrupting each other.
But the thing is the with the clock at the top of the mountain versus the base, you can dial out the acceleration effects, and it's basically primarily due to the difference in velocities that the time dilation occurs.
Interesting.
Yeah, but there's many experiments. I have a whole list of experiments that were done. Probably the list is of the classic or non-classic, the more modern verifications of theory of relativity. There's well over 50 well-documented experiments that demonstrate every aspect of special relativity and how to measure its effects.
Yeah, you got to watch out with your words there. Don't call relativity classic. That's different branches of physics.
Yeah, that's why I dialed back. More modern experiments, not necessarily classic. There are some classic ones, but more modern experiments that have been performed in the last 20 years to verify the special relativity theory. And we do it every day in particle accelerators, like at CERN and Fermi labs, and that when you accelerate protons and smash them into gold foil targets, the energies and the speeds that are attained are all predicted by Einstein's theory of relativity. And we use that in atomic research and high particle physics, high energy research.
Well, thank you very much. Because somebody over StingRay, shout out to you, Dean. I'm out of here. Boom.
Boom.
Laters.
So who's the other guy? Not Sagnac, but who's this? Morley? Did you say Morley?
Yeah, Michelson and
Michelson Morley. It's the classic null experiment, the experiment that was set out to find what's called the ether wind or ether drag, that failed to find it, that led to the subsequent development of the special theory of relativity that Einstein came up with.
So who was first, Morley or Sagnac?
Michelson Morley was the first ones. Sagnac followed about 10 years later with his ring gyro sort of apparatus. There was Michelson. Michelson first did the experiment. Then he brought Morley on board because Morley was a better practical man in terms of setting up experiments. And the Michelson-Morley experiment occurred over about an 8-year period. Michelson had some inconclusive data to begin with, and then he brought Morley along, and then together they designed the experiment, the apparatus, and then found conclusively that there was no ether drag or ether wind, and published their results, which we now call the Michelson-Morley experiment. And then there was Michelson-Gale, and then SAGNET came along with a different apparatus for showing the lack of ether drag.
Huh. I'll have to research him now.
Well, Michelson-Morley is the originators that basically set the whole ether drag and the concept of an ether threw that out the window.
Yeah, that threw the whole thing into a tizzy.
Yeah, because up until that time, scientists thought that light needed a medium to travel in, just like sound needs a medium. But the difference is, they didn't know it really at the time, is that light is actually an electromagnetic wave. It's a transverse electric magnetic wave rather than a longitudinal wave like sound is. Longitudinal waves need mediums where you have compression, rarefication going on. Like as sound travels out, we have your sound, its molecules, basically a pressure wave moving ahead, diffusing through the medium, and you end up with regions of pressure and high pressure, low pressure, high pressure, low pressure. That's what impinges itself on our inner ear and our eardrum that we perceive as sound. Whereas electromagnetic waves are totally different.
Could that pertain anything to Bernoulli's principle, sound waves?
No, it's not the same thing.
Doesn't Bernoulli describe pressure?
Yeah, but it doesn't. It isn't
Aerodynamic
in conjunction
pressure
with the theory of sound
describe
or
pressure?
how we perceive sound. Yeah, but
right.
Just because it involves pressure, how to describe the relationship between the velocity of a fluid moving in laminar flow, and then
it's fluids, isn't
down.
it?
Yeah, it's fluid dynamics.
Yeah, fluids include liquids and gases.
Yeah, right.
Right.
Now, the problem Michelson-Morley created, and as George was pointing out, at that time, everyone assumed that there had to be some medium through which light propagated, just like waves propagate through water. Well, there had to be this ether that light propagated through.
Yeah, they
And
wanted.
once they ran the test, they could not detect that ether motion that they were looking for. And now you got a real problem. You've got to either say one of two things: either the Earth is absolutely stationary, or there is no ether. And that causes a big problem, because if there is no ether, what does light propagate through? How does that work?
Well, they didn't find zero ether.
Well, the thing is like,
yeah, they did. They got
they
a
did
result.
not find zero ether drag. That's a misconception. Absolutely.
Well, they got zero. They got a null
found
result.
that the ether is not necessary. The ether is not necessary, and Maxwell's equations predicts that you don't need it.
They found
a medium
kilometers per second ether drag.
The thing is that Maxwell's equation, when Maxwell
ether drag, they suspected they should find, even though they knew nothing about whatever the material substrate of the ether is or how to ever really detect it. So they inferred from that there was no ether in the first place. But that's just, like I said, up to interpretation, isn't it? Because
no, it's not up to interpretation, because Maxwell's equations at the time showed us that there wasn't a medium necessary and for which light to propagate in. You look at Maxwell's equations, and Maxwell, after he put the 4 equations of electromagnetic theory together, Maxwell was a really good mathematician. He wasn't a physicist, he was a mathematician, and he took all of the known information at that time. He took Gauss's laws, Ampere's law, Faraday's laws, and he incorporated them all into a very nice theory. He showed how they were all interconnected, and then after he had the equations, he started manipulating the equations. He's going, holy shit, this thing is predicting a propagation of information at this extremely high velocity. And so that sort of set everything in motion. Up until that time, they had no idea how fast the velocity of light was, and the equation showed that light can travel through a vacuum at a very specific speed. It didn't require a medium. The equations show you that.
Yeah, but you don't know if there's a medium there or not
Oh, God.
yet. That's the whole
Yes,
thing with it.
we pretty much know that. There is no medium. It's not necessary.
Yeah,
But
you
there's
call
no point
space
talking
time
about it.
fabric. But then on the other hand, you say it's not a medium. But make
Well,
a
define
I
medium.
think Grim is
Define
coming.
medium. A vacuum is considered not a dielectric medium. Vacuum is it's your reference point. A vacuum is
yeah,
pure
epsilon.
vacuum is nothingness, nothing there. We don't call vacuum.
They call it nothingness back in the day, right? They used to call magnetics magic. Vacuums now are not.
Grim.
But we're not talking about Aristotelian physics or
Yeah,
metaphysics.
we're talking.
Yeah,
let's
but
talk-
we're I think Grim's coming across as the point that we're the argument of all the matter in the universe doesn't equate to the missing link, which
Well, we
the
don't
argument
understand it
of,
all at
all
this
the
point in
matter
time.
in the
Doesn't
universe
mean
Right,
we
that's
won't
all I'm trying to
understand it in
say.
the future.
A lot of times we think we're interpreting a thing just perfectly, yet that's what's
Well, we
blocking us
don't
from actually
understand.
seeing the truth because of our false interpretation of what we thought.
Yeah, and you know the truth. We know that.
Well, I'm not saying I know the truth. I'm just saying that I don't think that we should just sit here and say we know the truth, which is exactly the opposite of what you say I'm saying. So I don't know where you even are sometimes.
So well, you know, the standard model that we have works pretty damn well.
Pretty damn
So-
well, right. So does that mean that all the children should not be interested in learning anything new about science now?
I never claimed
Not
that.
be trying
I
to.
never
Nobody
claimed
said that at all.
No one here
Well, I
is
know, but with
claiming
that
that.
defeatist attitude.
I just don't
all
understand
about
this burr under your saddle that you seem to always have, Grim. No one's claiming that. That's what, you know, scientific investigation is all about, is trying to expand our understanding, refine our understanding. A lot of times
Right, and what kind of
we, get,
message are we
we,
sending?
we find
Say,
something that doesn't
already
quite
understand
fit,
it all.
so we go
already
and try to figure out how we
Try to
can
figure out.
modify our theories to incorporate the new observations. We don't necessarily have to throw the whole theory out. We just have to massage it a little bit to incorporate the new information. And that's how it progresses. Very seldom have we ever had to scrap a whole theory just because of some new observation.
I know. See what I mean? See it shouldn't be that big of a deal for you. Bias. It shouldn't be such a bias. Like we have to scrap a whole theory because it's not actually scrapping a whole theory. You know, it's just saying that sometimes what you interpret as observational proof of your theory can also be something else instead of just that.
Yeah,
And
exactly.
No,
it's
I don't think we call
it's
that.
like a puzzle. I mean,
right. If
just
there's an
like
answer,
Maxwell
just a
came
second.
across all these
I know you got a thought, man, but so do I, and I'm trying to finish it. So it's just, you know, it's like when we have two answers for the same observation, we choose one by decree because it best fits our theory or our proposed hypothesis.
No, it's not by
That's what we're
decree.
doing in science
It's by incorporating all the experimental data that we have, and over time we've built up this theory, which we call the standard model, which of course experimental data also being have looked at through another point of view through string theory and stuff. But so whatever the ultimate theory is going to be, it's going to have to incorporate the standard model because the standard model works so well. There could be a larger overall theory, which we are looking for. It's called the TOE, the theory of everything, where we're going to incorporate
Let's talk about
gravity
cosmology for a second.
into the other three fundamental forces. And once we understand gravity at the quantum level and at the very large level on the order of several galaxies, we will have a complete theory. We're not quite there yet. We have 3 of the 4 fundamental forces incorporated into
George,
a
I heard you, man. I got you roundabout the first time. You mind if we break in for a conversation? I'm not trying to be rude. I mean, you're sort of
No,
Giscow.
you are always
Trying to make a point for the past, you know. So anyway, if we talk about a specific instance in cosmology, where there are observations that are being made that falsify the original hypothesis, yet instead of falsifying the hypothesis, they're just adding it to the hypothesis, like, oh, well, maybe.
Well, that's the first thing you try to do. You try to see if there's a way to modify your current understanding to incorporate the new observation.
Yeah. No, that's not really what you do, because especially
yes, that is what you do.
When you originally
that is
made
exactly what you do.
Well, not in this particular case, my man, and I'll explain why if you allow me. Thanks. So when we made these original hypotheses, we didn't know there were electric currents traversing these vast distances. They didn't even know that Birkeland currents or aurora were from charged particles from the sun igniting on the, accelerating around our magnetic field there. They didn't understand that that was even part of the equation then. Yet these guys knew that it was all about gravity that was doing all the heavy lifting in the cosmos, and all the, it didn't leave any room out because it was to the T. Remember, gravity does it all to the T now. And so there's no room for anything else to be imparting action on any of this matter out here. Yet there is all of this action being imparted on this matter by these electric currents. And we know it is, because we know the electric forces,
again, you don't know what you're talking about. I have done some calculations of what kind of currents are required to induce the kind of magnetic force effects that you're talking about, and you just
we're not talking about fully. See, that's the thing. You
don't know what you're talking. You have no idea. I have asked you for over a year, Grim, to present me with some equations that show me how these so-called current filaments and that in space can account for the forces that bind planets together. You've never been able to do that.
Bullshit.
No, you have never done that. I have asked
star
you
formation
to put
article.
a lecture together. I've asked you to put a lecture
George,
together.
I'm going to go ahead and tell you, I've linked you to star formation
so that I
article.
can analyze what you are talking about, because
I've given you the double layers of astrophysics. I've given you the double layers of astrophysics.
No, you haven't given me anything.
Bullshit.
You haven't put it together. All you've given me are these random papers that you look at titles and say, oh, well, this kind of looks like it's got the keywords.
Okay, so
you start reading these things,
and
so it contradicts what you are telling us. You have never read and understood.
I don't know if it's possible for these people to believe you, really, because
you have never read and understood these papers. All you do is kind of like Quantum Eraser. You present these citations. You have no idea what the citations are talking about, what the content of the citations. You're just
mapping the electric current right now.
Put something together for us, Grim. We've been asking you this for over a year. Just give me a nice, short synopsis of the overview.
I heard you, buddy.
You show me where I went wrong in my calculations, showing you that the electric force can't be responsible for holding the Earth in orbit about the sun. You've never been able to show me that.
Because I've never claimed that that is the only thing responsible for holding the planets in orbit.
It's the only thing that's needed.
You've created
the whole theory of gravitation, Newtonian mechanics, explains it to a high degree of precision. There's no wiggle room. There's no room for anything else.
This kind of shit.
There's no room for anything else.
Yeah, but why don't you just back and forth?
Yeah, but how can you even say that, George, when you earlier were saying that if you don't question and you don't explore new ideas and options, then we're going to never advance science.
Maxwell, that doesn't follow from what they're talking about.
If you listen, the claim he's making is he says that Newtonian gravitation does not account for everything
not saying only electric
No,
force.
that's what you're saying. You're saying that
No,
there can be possibly something else
idiot.
other than
I said
gravity
it over and
holding
over
the
again.
Earth
I'm
in
saying
orbit
it again
above the
right
sun.
now to clarify, to make sure you understand that's not what I say. And you're still telling me that's what I say. So I don't know where to go from there, fucker.
No, that's what you said.
No, it's not.
You said it doesn't. Okay.
Look, do
let's
you
back
mind
up.
if you shut the
let's
fuck
go
up
to
for a minute? I'll
fundamentals.
clarify
No,
to
back up.
How I want to why
What is holding?
You're
What
strawmanning me over and
explains
over
the Earth in orbit
don't
about
care
the
to
sun?
clear up your straw man.
What forces hold the Earth in orbit about the sun? Let's start there.
Yeah, let's say gravity. Gravity hold the Earth in orbit around the sun for the most part.
No, wait,
so
for
how
the
come
most part.
how come
No.
light couldn't be a factor?
Yeah, it actually is. Light actually makes things heavier.
See, that's my point. I mean, here's
More to this.
somebody that is a firm believer in our standard model that says that there can be no other force whatsoever other than gravity and Newtonian physics or whatever to show that that's what holds our planets in orbit. When in fact, I mean, there's probably not completed science that also contributes to the factor.
You're just pulling crap out of the air. They're
You're interrupting him too.
Show me, what is it? Because the Newtonian physics
you don't want to look like an asshole,
to a high degree of accuracy to many decimal places.
Try to pretend like you're the victim.
5-6 decimal places. Newtonian mechanics shows us and predicts everything we see about planetary orbits. Now, if you want to claim that there's some effects of light,
and you know it.
Nonsense or other things, then show us.
I'll tell you
show
why.
me where the corrections need to be.
The
in
reason why a planet is supposed to have a magnetic field,
electric effects, electrostatic or magnetostatic effects.
off axis to its plane. It's a orbital plane. That's why a planet is supposed to have a magnetic field, right? Because it spins off axis to the orbital plane, right?
What?
That gives it a magnetic field, right?
No.
So why does
magnetic field is due
No.
axis alignment
That
to
doesn't have anything to do with the magnetic field.
Circulating currents within the interior of the Earth. Move a current.
Undulating current.
Field. Moving charge is current.
Yeah, but you know that doesn't work because it's a uniform electric field, magnetic field, and you don't get that with what you're calling undulating currents without an actual causative current creating the magnetic field.
Convection currents will produce a steady.
No, they don't create such a homogeneous magnetic field.
It's
been tried over and over
Put
again.
a constant current in a wire, and you have a non-fluctuating
It's been
magnetic
tried. It's
field.
not true. It doesn't work.
Can I ask a question
to 5 or 8 different poles? There'd be magnetic poles everywhere. It wouldn't be one fucking 2 poles like it is in this. There would be just little bursts of magnetic fields everywhere. It wouldn't be a big fucking toroidal donut around the entire planet.
One of Maxwell's equations is that the divergence of the magnetic field has to be zero.
Wait. Can you guys stop arguing a second so I can ask a question to George?
Yeah.
Or Big Blue or whoever can answer it.
Answer.
So our Earth's electromagnetic field, doesn't it not block out some of the harmful radiation coming from the sun? And
it captures it. It's not electromagnetic. It's a magnetic field.
I'm sorry, magnetic field.
Yeah, yes, it does. It deflects the particles. Yeah.
So it deflects. It deflects some bad particles, right, and lets some.
Yes.
Okay. That's all. That's just.
So
it's like a filter. So it's
without the Earth's magnetic field, we would have a lot of genetic damage due to high energy particles coming down to the surface of the Earth. Without the Earth's magnetic field, it'd be pretty destructive for us.
So magnetics. Boy, that's interesting. Man, because all I do is come on here and freaking get more questions. I guess that's a good thing.
The thing is, I mean, you can easily demonstrate this. I mean, that's what was done by Compton and a few others. You take a tube, a clear tube, like a fluorescent light does, and you rarefy. You pump out the air in there, and you put in a certain gas, and you put it, say, between poles of a large magnet, and you shoot an electron beam, and you'll see that beam will curve. a moving charged particle feels a force in a magnetic field that causes it to deflect. And that's what happens out in space with the Earth's magnetic field. If you have charged particles moving through a magnetic field, they will feel a force and they will be bent. And how they get bent is given by the right-hand rule. Whereas if you point your index finger in the direction of the magnetic field,
The left-hand rule.
Yeah, the
it's
Lorentz
called the
force.
right-hand rule.
Oh, that's the right-hand rule.
Lorentz law is what it's called, or Lorentz force is what it's called, actually.
Yes. And the way you determine the vectors is if your finger points in the direction of the motion, say, of the particle, and your middle finger points in the direction of the magnetic field, and you rotate your index finger into your middle finger, your thumb points in the direction that the positive charge will deflect. So
Perpendicular to the charge.
if a positive electric charge goes into an electric field, it's going to be, say, if it's going in horizontally to the plane of the Earth and the magnetic field is also in the plane of the Earth, the particle will bend upward. The charged particle will bend upward. It will be deflected in a circle. Try to go in a circle in the vertical plane.
Because the magnetic field.
So how come they don't have super cooled electric motors?
It's not practical because it's hard to keep things at liquid nitrogen temperatures. It's expensive yet. That's why we're still hunting for room temperature semiconductor or superconductors.
No, you're saying by turning
the very highest
turning the mechanics backwards and making it a take away heat instead of add heat, right?
Well, the thing is
I wasn't talking to you.
that's the one of the holy grails in materials research right now is trying to find superconducting materials that will operate at room temperature.
Yeah.
That the best we can do right now is a little bit above liquid nitrogen, which is around 90 degrees Kelvin. That's about 190 degrees below zero.
I think bismuth has some pretty interesting properties.
Yeah.
Well,
there was something interesting that I read about here just a few weeks ago. One of the Japanese research groups were having a celebration, and they were playing with some superconducting materials at the celebration. Somebody had dropped one of these in a glass of red wine, and it exhibited some really interesting properties that kind of led them onto a new path into high temperature superconducting research. So we'll see if that leads to anything.
Isn't nitrogen one of the most abundant properties of our atmosphere?
70% of it.
Composition, it's over 70%, but that doesn't help us. You got to cool it down to liquid nitrogen temperatures to keep your.
Well, if you compress it, doesn't it?
No, not automatically. You have to take nitrogen gas to compress it enough to force it to form a liquid. Takes a tremendous amount of energy.
Are you familiar with the physics behind the superconducting bismuth? I posted a link there. I remember reading about it a couple years ago. I guess it's been 3 years almost.
No, but that's the big exciting area. You know, this whole thing blew up around 1985 when they discovered, the yttrium, and combination of certain ceramics that exhibited superconductivity at liquid nitrogen temperatures. I mean, there was.
And usually they have to exhibit like a superconductivity, they'd have to have one mobile electron basically per atom. But in bismuth, it's one mobile electron for every 100,000 atoms, and it's still a superconductor at negative 273.15 degrees Celsius.
Well, everything is a superconductor at absolute zero. So
Well, it's above absolute.
Not everything, Big Blue. Not everything. Not every material becomes superconducting at absolute zero. Only a few materials do. But the thing is, what we're trying to do is develop materials that will exhibit superconductivity below or above 90 degrees Kelvin, which is liquid nitrogen, because we can do some things. You've probably seen these skateboards or hoverboards that they've done where they have a skate park with copper, and what you do is you fill your board with liquid nitrogen, and the magnets in the board exhibit superconductivity, and then you can use Faraday's law of induction to levitate the board, but that's only good for several minutes until you run out of liquid nitrogen in your board. What happened?
I don't know
Sorry,
everything,
I've
but we're
completely
back.
sidetracked. I'm looking at helium-3 because liquid helium is some pretty cold shit.
Oh yeah, liquid
much colder than
helium
nitrogen.
has some very strange properties.
Yeah.
It's really cold.
I went to York University once, and they have a room that contains what they believe to be one of the coldest places in the universe. They've got a tiny box that they've cooled down to almost absolute zero. And that was a helium-3 refrigerator.
Oh, what's interesting about absolute zero is not all motion stops. There still can be crystal lattice vibrations.
Yeah, did you see that they're growing perfect crystals in the space station?
Yeah, you can do that. I mean, we're pretty good here on Earth too in growing very pure crystals. That's what the semiconductor industry is dependent upon, is being able to grow very pure silicon ingots.
I get. Did you see the Philosopher's Stone deal? Well, did you see that they actually converted mercury into gold?
Well, yeah,
And
you
it,
can do that.
and
You can transmutate elements, but again, it's not practical.
yeah, it took so much energy that
Gold is cheaper.
yeah,
Yeah,
exactly. I just thought it was interesting. It was pretty cool.
That reminds me of a Twilight Zone episode I saw the other night. It was really cool. These three bank robbers found a time machine. They went and robbed the bank of all this gold, and then went into the future, and they thought they were going to be really rich. And it turned out that prior to their arrival in the future, mankind had figured a way to manufacture gold, so it had no value.
Kind of stuck at that point, huh?
Yeah.
No going back.
Oh shit! All that effort for nothing.
Yeah, and I can't go back. Shit.
I was wondering why I didn't hear anything that sounded like a Bond villain. Arwen left. Oh well.
Yeah. But the whole thing on research into high temperature semiconductor or superconductors is very fascinating. I mean, that's kind of one of the holy grails right now, because if that ever comes to fruition, I mean, the world is going to change dramatically. I mean, the whole thing about power transmission, lossless power transmission, and high efficient motors. I mean, even what's been done here in the last 10 years with neodymium magnets, right? You can build now a 1/4 horsepower motor about the size of your thumb with these neodymium magnets. It's really quite incredible.
Yeah, yeah, I don't think they'll, I don't think that, I think that they probably already have technology like that, but it's just not.
No, they don't. No, we don't.
You don't think
It'd be
so?
a big deal. No, nobody is hiding high temperature superconductors. That would be such an incredible moneymaker.
Moneymaker, it would kill the economy, it would kill everything.
No,
Big energy would lose out.
No, it wouldn't. No, it wouldn't.
No,
You
Big
still have
oil,
to
big
pay for
energy.
All it does is it reduces the losses in systems.
that will just
It
make more money.
increases the efficiency. It doesn't stop the development of energy generation and distribution.
Yeah, if you
It's
could
not
make
like free energy.
if you can figure out a way to make power lines that have zero electrical resistance, that would make utilities tons and tons of money.
Yeah,
Unbelievable
Yeah.
amounts of money.
right
Yeah.
now, I mean, like our current generators used in generating power, they're over 99% efficient. To get that extra 1% is a big deal in the power industry. I mean,
See, that's the problem I have with efficiency. What definition of efficiency are they comparing it to?
well,
Power
power generated
loss
versus
divided by
delivered.
power out. Yeah,
Yeah,
it's
power
losses
generated
divided by
versus-
output.
How much power can you deliver from what you generate? That's all. Right now,
Yeah, but
power,
I mean, so then realistically, power generation from a gasoline generator is super inefficient. I mean,
Yes, it is.
yeah, yes, it is. Yeah,
Absolutely. Power generation from the burning of coal is very inefficient. It's not more than 30 or 40% efficient.
but room temperature superconductors will not change that.
Not a bit, because it's all thermal loss in the cycle.
right.
You can't recover 100% of the heat produced when you burn fossil fuel.
Yeah, what high temperature superconductors will change is in the delivery method. I mean, will reduce the losses of transmission lines, which is a big deal for power companies.
That's the main thing.
If they can improve their efficiency by 1%, that's a huge deal in a $1 billion industry.
Yeah, you can reduce the losses in transformer, in the windings anyway, in transformers, and that's the largest part of the loss. Some of it is in the core, of course.
I think somebody's going to come up with a way to suck the energy out of the radio waves in the air and cause a huge crash of all of the information that's used.
That's a fallacy. There's very little energy density in the atmosphere. I went through the computations once. If you look at the static electric field in the atmosphere that surrounds the Earth, the total energy stored within the electric field of the atmosphere surrounding the Earth is about the equivalent of 2 nuclear power plants. That's it.
There's a company in Texas that is experimenting with that right now. They've been doing it for quite a while.
There's no point. Don't you get it?
No, I get it. I was just stating that they're.
I'm saying you can't get something out of nothing. The thing is, the total amount of energy stored in the Earth's atmosphere is about the equivalent of 2 nuclear power plants.
Yeah, but it's not from nothing. It's from the transmitters around the.
Wait, George, what you're missing here is not George. I'm sorry, Maxwell. What you're missing here is, because there is so little, researching it is fruitless because you can't generate more than exists. So what's the point of 2 nuclear power plants when the world would need hundreds or thousands?
No, this wasn't for a power plant scale size operation. This was just you guys miscomprehend. Misunderstood what I was totally saying.
I know where you're headed here, Maxwell. What I'm trying to tell you is that even with all the electromagnetic energy that's pumped into the atmosphere from the TV stations, FM stations, cell towers, all of that taken together, once you get away from these sources, the energy densities fall off so fast that you can't extract much. That's why, like with the companies are experimenting with these hotspots around cafes and in cities and stuff where you can charge your cell phone, but you have to be in very close proximity to do a wireless power charge of these new types of cell phones and stuff. Once you get hundreds of feet away, the
Well,
densities fall off so fast that
it's the
you can't
inverse square law.
extract any energy.
Yeah, I wasn't saying that they were going to get more from nothing. I was just,
But I'm saying you can't extract any useful energy out of all the electromagnetic waves that happen to be in your living room.
Well, that's the point. It's just not. It can it be done? Yes. Is it practical? No. It's
No,
not.
the energy density isn't there for you to extract enough energy to be useful.
but what I was saying was that if somebody were to come up with something that somehow sucked in all these electromagnetic
Oh,
waves,
again,
it would cause a huge crash. It would
No,
cause
it
a
wouldn't.
huge crash
No,
of the information network.
No, it wouldn't.
It really couldn't. There's not enough power. It would get sucked in.
If suddenly there becomes that much power floating around free in the atmosphere, you won't need to worry about it because your ass is going to be vaporized.
Yeah. You can't extract any more energy out than is currently there, and the energy densities aren't there to give you enough power to power up even, a very cheap small cell phone. It's just not there.
What are we talking about per cubic meter, George? Are we talking about picowatts or nanowatts or what?
Oh, less than picowatts.
Less than picowatts per cubic meter. Yeah,
Fermento, was it not fermento? Femtowatts.
very, very
Probably
small
more on
amount.
the order of femtowatts. Your typical FM signal that you're receiving, the sensitivity of a typical FM receiver is on the order of 15 femtowatts.
It's not very much.
No.
Yeah, that's 1/thousandth of a billionth, or 15 trillionth of a watt.
I don't know. My CB radio, when I had 1,000-watt boot, it sure did a lot of damage.
Only nearby. Only nearby.
Like what would have happened if the FCC would have caught you with that damn thing?
I don't know, but after I heard one of my friends got blasted for like $100,000, and
Oh yeah.
yeah.
Well, that happened back in the 60s when I was growing up, when Class C transmitters, receivers overlap the upper channel 23 of Citizens Band Radio. We'd get skipped coming in. We could hear garage door openers going on and off, and you could open up people's garage doors in Indiana from northern Minnesota during a skip event, going up on channel 3 and playing tones on your through your
That's
CP
funny.
transmitter. Yeah.
People are like, "What the hell's going on?"
Yeah, they took the 11-meter band away from the amateur radio operators and gave it to Citizens Band.
Right. Yeah.
And I was a ham radio operator when they did that, the son of a bitches.
But the thing again, Maxwell, is the energy densities just aren't there. Even with your 1,000-watt linear amplifier attached to your CB radio, once that wave
Propagates out, it dissipates.
away from your antenna, the power densities fall off very quickly.
Yeah, you can light up a fluorescent tube if you get it within a few feet of the antenna, but 4 feet away from it, nope.
So again, you just don't have enough latent RF energy out there to extract anything useful. If you did, it would be probably affecting many other things in our life if you had those kinds of RF energy densities floating around the atmosphere. you'd be inducing currents into things and creating all kinds of havoc.
For sure.
Yeah, I can't remember that place in Texas, but I don't know what they were just using it for just to charge a solar bank, a battery bank.
Yes, again, I mean, that's been one of the proposals, is like putting up a large solar photovoltaic array up in orbit about the Earth and beam down microwave energy to a receiver on Earth to convert the power. But when you go through it, it's just such a ridiculous concept. But this thing rears its head every now and then. It keeps getting circulated around. There's just too many losses and practical issues surrounding such a thing.
Well, it's sexy sounding though, and
Yeah. I mean, you could do it where if you had a beam that was about a mile in diameter, the energy densities there wouldn't be large enough to harm anyone flying through the beam. But how do you? It just doesn't make sense in terms of building such a huge receiving array, being a mile in diameter or whatever on the Earth, and then you're subjected to atmospheric conditions. There's always absorption through propagating through the atmosphere, no matter what frequency you choose. Some frequencies are being absorbed less in the atmosphere than other frequencies, but you're still going to have a fair amount of absorption.
have a lot of cleanup too, trying to pick up all those dead birds you're going to kill.
Yeah, so I always just kind of smile when I hear about these claims about being able to get free energy out of the atmosphere and extracting energy out of the atmosphere, and how it's going to kill the power industry and stuff. And it's just never going to happen, because you just don't have those kinds of energies to extract to begin with.
Well, it's not really free. It's not.
Well, that's it.
It's got to come from somewhere, right?
Yeah, the only free energy I've ever been able to take advantage of is at nighttime going over to my neighbors and siphoning gas out.
Well, I mean, you can consider solar and wind free, but then again, it's really not
really.
because
There's a cost associated with it: manufacturing costs, the mining for the rare earth elements that go into there, and disposal costs. After lifetime, I mean, it costs. It's not free.
That's large cost involved in extracting it or converting it into something that can be used.
Yeah, you have to look at it as an alternate source of energy. It's never free.
It's a good alternate source, though.
Oh yeah, I've got solar panels I've been playing with. I mean, it's really a lot of fun using this stuff. I mean, even here in northern Minnesota, I can get a fair amount of power, energy extracted through the day on a solar panel. One of the biggest problems I have for the summertime, of course, is I have to come up with a good tracking system, because our sun in summertime wraps around the back, for a good portion of the day. The sun is in the sky for 16 hours. And so the sun rises and back. If I face the panels due south, the sun comes up in the morning for about 3 hours and it's behind the panel. And the same thing near sunset. As I get past about 6 o'clock, the sun starts going behind the panel. So I kind of lose a lot of opportunity for about 6 hours out of the day, because the sun is behind the panel.
Yep.
So yesterday I was on, I think, Q's chat, and they're talking about the moon landing and blah 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 blah, and they asked everybody why they thought it was faked, or if they thought it was fake. And my only quorum was that they didn't have the battery technology. Well, I did some more research and found out
Oh,
that
yeah, they did.
now they're saying that they had. Well, I said they. Yeah, exactly, they did. So they used thermocouplers, and I was just
Well,
astounded.
think about this. Lead acid battery technology hasn't changed much in 60 years.
Yeah, but those
Well,
weren't lead
exactly.
acid.
Yeah.
Those were definitely not lead acid batteries.
Right,
Those
but I'm
No.
just saying that there was
were
battery.
silver zinc. I
You
think.
had battery technology that you could make use of. I mean, they had fuel cells and things.
Yeah, I think they used silver
Yeah,
zinc.
they used fuel cells with thermocouplers.
Well, no. Fuel cells were used in the command module, not on the lunar modules.
But the thing
Lunar
is,
modules used I believe they were silver lead or something. I don't know.
yeah.
You can
Well,
look at it. Silver zinc.
the bottom line is, Big Blue, they solve the technical issues.
Yeah. Thermocouples are used when they have little nuclear reactors on board deep space missions.
To use thermocouple, you have to have
You got to have a
very
source
high
of heat.
heat generate,
Yeah,
very high temperatures in order for thermocouples to be useful for a
That's
source of energy.
that's right. So
But the
kind of
thing is they obviously solved the technical problems back then. It's crude by today's standards, but it worked.
So do you use that in-ground heat up there in Minnesota? That
In-ground, you mean geothermal?
yeah, geothermal.
Some people do, but it's
Is that
I'm surprised it hasn't come into vogue more because um, there's two issues. I was looking into doing one using the latent heat in the lake I live on, but there are so many regulations regarding putting anything into the body of fresh water. Is it has to end up being a closed system. That's only what is legally allowed. You can't say pump water out of the lake, extract the heat, and pump it back. It has to be a closed system.
yeah, the regulations, damn, get you every
But the
time.
other way, I have a friend that actually had a well drilled. He went down about 1,000 feet, and you pump out the hot or very warm groundwater and then extract the heat and pump it back down. And that worked very well. But, it's an expensive endeavor. There are certain parts of the U.S. where it makes more sense. Like, if you go around Wyoming where they have, all these hot springs and things like that closer to the surface, you could probably make good use of it. But, there's no real silver bullet that helps everyone. You have to have all these various alternatives to draw from alternative sources of energy. I'm a real proponent of having a lot of different options and choices and distributed, sources. You got wind power, solar power, photovoltaics, geothermal, and all that. In some parts of the country, one makes more sense over the other. Here we have
Yeah,
some hydroelectric power because of the large waterfall that goes from out of our lake into Rainy River that flows along the northern border of Minnesota. So different parts of the country makes more sense. And, until we solve the Holy Grail, find the Holy Grail, another one, fusion power, solve that problem, it's going to be necessary to have all these various alternatives.
Speaking of fusion there, George, what do you think about Skunkworks' ultra vacuum chamber that they're trying to do it with?
Yeah, there's two companies that are getting investment money and are claiming that maybe in the next 5 years they're going to have something, but we'll have to see. It's been one of these tough problems to solve. You look at the Princeton Tomahawk reactor, they've been working on that for over 30 years now. The containment is the real problem. Some options are using high energy, high intense lasers. the pressure from those light beams to hold the fusion products in a light container, so to speak. Others are using magnetic fields to contain, to create a magnetic container. Some of these programs have developed break even. I know we're at that point, but the trouble is it doesn't last for very long. It only lasts on the order, I think, of milliseconds for the break-even fusion generation. So we got a ways to go, but man, if that problem ever gets solved, now that is going to be a game changer in the power industry, of course.
Yeah, I can't wait for that. I wish I could add something to that, but you nailed it.
No, it'll be a huge change for mankind if we ever solve the fusion generation problem.
Oh, I think it'll get solved eventually.
Yeah, eventually, but we're not quite there yet. I don't know. Like I say, some research groups are saying maybe we're about 5 years out. I'm just going to say wait and see. I'm not going to.
Yeah. Well, I think we're about 5 years out from being 5 years out.
Exactly. That's how it's been. I mean, when you start getting close to perfecting some of this stuff, you find a gotcha or something that you've got to work around, and you keep bumping into these brick walls.
Goddamn Newtonian physics gets in the way.
Yeah. I mean, there's a lot of good research going out there. This is a great time to be alive, and is a great time for young adults. I mean,
It really is. It really is.
if I was a young adult, if I was in my 20s, man, I'd be like a kid in a candy store trying to figure out, which one of the new high technologies I want to go into.
George, can I ask a quick question?
Yeah.
Or George or Blue, or anybody actually. What type of energy, or where do we see a quadratic fall off?
Quadratic, like
Yeah.
a fourth power?
Yeah.
None that I'm aware of.
Okay, no, just wondering. Because my flat Earth model, I've managed to illuminate just what should be illuminated, but in order to do so,
You can't make it work.
So the light, I've got a fall off that is quadratic, and I can do it. So, but I'm just wondering, is there any occurrence anywhere in physics that?
Yeah.
No.
No, the closest you're going to get to that is like in the near field, electromagnetic field, a magnetic field, and what we call the near field will fall off as a cubic function.
Yeah.
But I'm not aware of any fourth power. There is a fourth power relationship in.
Oh no, well, sorry, no,
temperature.
Sorry, I tried it.
Yeah,
no, I tried it at quadratic. I've actually got it cubic at the moment. That's the only way I'm able to do it. Not quadratic. That didn't work. It's still the fall off based on the distance is still too great. Whereas cubic, it does.
Oh, it works cubic.
Well,
well, the thing
I'll tell you
again,
what. I'll share my screen. Works is a very
well. The thing is that
loose.
The cubic
thing.
relationship
Reminds me of like an electric field for a dipole or something.
Exactly. I mean, in the near field, Grim kind of hit it on the head there. If you look at a dipole, an electric dipole where you have a positive and negative charge separated by some distance, within the near field, that goes as a cubic. And of course, it has to if you think about it, because if you get far enough away when you're looking at a dipole, it looks like the positive and negative charge merge and cancel one another out. So the field does have to dissipate rather quickly out.
Or does it just change direction?
No. If you look at it, the charges, the fields of the two charges essentially.
No matter how you look at it, it obeys that inverse cube law, whatever.
Okay, what you got?
Oh no, like I'm saying, the way that I was able to to not have the other side of the disc fully illuminated is just by going to a
I see what you're
a
getting at,
cubic
sure.
fall off for the energy of the sun.
Well, maybe the sun can carry an opaque portion of the atmosphere along with it.
Yeah, it doesn't seem to be illuminating half of the globe as it should, though.
Well, it's the closest I've got at the moment to reality. I'm not saying it's a solution to anything, because wait a minute. So here in the UK, no.
I would say that the flat earthers would say that yes, that absolutely lights up the entire globe, or the entire half.
Every time you fix one problem, you just create two more.
There it is. You see it? It's lit there.
Yeah.
You see it?
Yeah, I see. It's pretty fucking dark where you're talking about.
Yeah, there's not very many hours of daylight in this with this cubic fall off, to be honest. We've got about 3, if that, I think. But, well, maybe light's got some property whereby it hangs around after it's excited things. I know.
Yeah, why don't we call it latent light?
It's the fart principle, where the light lingers.
Nice.
Dean, you could call it latent light. Light that's just kind of lazy and hangs about.
Yeah,
lazy light. How about lazy light? That would be
George. How about the new discussion of tired light?
Oh, there you go. Tired light. Yeah. Just kind of sitting there drinking a beer.
Well, that's
He worked all day and he's just tired, kicking his feet up.
That's pretty much been my theory of why the other side of the Earth they can't see the sun. It's just the light just gets tired and falls down. It can't go any further.
Yeah.
Well, there might be a business opportunity there for us. You, Grim, and I, and Dean can get together, and we can go collect up those tired photons.
Hell yeah!
Where do they go? They must be laying around
I thought you were
somewhere.
going to say we could make flat Earth T-shirts since I have a T-shirt company. Boom.
You should make flat Earth T-shirts. So good.
I know. I almost thought about it, but I just didn't want to be the asshole just sitting there making money.
Oh no! What you could do? What you could do with your microscope is just do more fucking microscope shit of anything, and then turn it into a pattern for T-shirts. People won't know what they're
I've
looking
been
at.
wanting to do is find the way to the edge of the Earth so that I could start a universal waste disposal company.
That would be
Shove
cool.
it off the edge.
World's garbage and dump it off the edge.
Heck yeah, just throw it over the side.
Problem solved.
Especially, think of nuclear waste disposal. We'd have them. We'd own the market.
Rapists, child molesters, murderers, off the side.
Yeah.
Yeah, solve the prison problem.
You know what? It's ice, right? They just carve a nice slide into it, make it fun for their last little ride.
There you go.
I slide right off.
Yahoo!
Yeah. What I should build onto this model then is a little plank on the edge.
We could make the ride really. Yeah, we could make the ride really thrilling, Grim. We could do a bobcat run off the edge.
Oh, geez,
bobsled, I mean.
Add some swerves in there and shit.
Run off the edge, yeah. Go off the edge at 120 miles an hour.
A couple loop-to-loops and then like a ramp that goes straight up. And a sign on the back of the bobsled that says, "Still don't believe in gravity," and make them land. No, I'm just kidding. It's getting bad.
Yeah.
Sorry, everybody's imagining.
Yeah, there's a lot of opportunity here in all this fantasy.
I'm still thinking of what good things can we get under the microscope to create T-shirt patterns out of. To be honest.
Yeah, it's all so much nonsense. What I find kind of dismaying, and I'm not sure what's doing all this, is over the last month, all the hangout channels that have popped up, everybody wants a piece of the action. It's like for a lot of these hangout squatters, they've got like, it's like 24/7 everywhere with, I mean, my God, the number of channels, and I hear proposals for more channels. I mean, we got Ranty starting, and
I'm in it for the private hangouts afterwards.
yeah.
I don't want my kids to find me on a flat Earth hangout anymore. You know.
There you go. Yeah.
Yeah. Like, oh, son, I don't believe in it. I'm just there laughing at them. Well, that's not any better, Dad. I'm like, well, you're right. You're right.
Yeah. Well, sometimes it takes a child to kind of
I
bring
know.
you to your senses, doesn't it?
It does. Because my inner child was not telling me that at all. My inner child was like, go fuck with them.
Yeah. Yeah. And why, Dad?
Exactly. I mean, you only live once. Man, oh man.
But it's the same stuff regurgitated. You know, there's a handful of favorite subjects, and it just gets recirculated all the time. You know?
Yeah, and there's a couple, there's like I call it a hierarchy, but it's like a leadership who will spit out the first, if something's going to change, if the new thing is to be talked about this week, it comes from 2 or 3 particular people.
Yeah, it's either going to be the Nathan Show or Globusters. It's going to toss it out there for the sharks to chew on.
The worst part is the Nathan Show hasn't produced anything worthwhile. Since Quantum Eraser's been on there, it's been the exact same nonsense.
Oh yeah, I mean, Quantum Eraser and Nathan, that show is basically deteriorated to where I think it's amusement for Nathan and Quantum Eraser to basically stroke one another on their perceived brilliance. You know.
Lou, you were on yesterday. That's when we were talking about it. Does anyone else find it amusing that Nathan talks about people being religious zealots, but he has an actual religious zealot on his panel?
It's got to sting every time he hears him say it, a little bit.
It's extremely amusing. But like my father told me many years ago, be careful what somebody's accusing you of, because that's probably exactly what they're doing.
Mm-hmm. Whether it be farting or cheating.
Yep. When they level those allegations at us as science being a religion, it's just, that's.
I think the saving grace in all this, Lou, is the fact that if I pop in every now and then, every few times a day, I open up Nathan's show to see how many viewers he has. And I've been noticing that he topped off out a while ago at about 280, and now with Jose's show opening up, Nathan's show is, lucky if he makes it into the 200s now.
Yeah, and now it's going to go even lower with the show of Ranty, the Flat Earth Prover.
Yeah.
Why is it so interesting? I just never really.
I wanted to answer today when Jose was going around and answering. And do you know what it would be? Morbid fascination would be my description of it. When you see something coming and it's a train wreck and people are attached to it and it's gonna slip away from them. It is that kind of thing that everybody kind of finds interesting. Well, how are they going to react?
Yeah, I guess. Yeah. I meant from their perspective.
I don't know. I got no idea.
Yeah, I couldn't get it.
I see. What was the event that everyone was hyping for so long that was going to be awesome? It was going to be for something associated with Tumblr, and it wound up being like 20 people in a warehouse that had a small ball pit in it, and that was it. It's that sort of fuck up.
I don't even keep up to date on that stuff.
I'll have to find it. It was a couple of years ago.
Well, I'm a little bit pissed off because I can't do a real-time chroma key of this hangout on the stream, which is what I'm pissing around with at the moment.
What was Arwen on about? He was having an issue with the setup of a of an interferometer.
I
Yeah,
have no idea.
having a problem.
Aardvark just has problems. That's all you can
Yeah,
say.
out of all of Owen's problems, you bring that one to the table. I'm pretty sure he's got a few bigger ones than that, to be honest.
I just don't understand why he's thinking that he can use a double slit experiment for what he wants it to do, but it can't work for anything else. So he's got a problem with it being set up exactly the same way. I just don't understand that.
I just don't understand Owen.
It's Arwen. I don't get it. How these guys think that for some reason or the other, they've got it in their minds that you make it through the third grade and then just skip everything until your junior year in college and pick up there and move on. That seems to be the way they want to go with things. Jesus Christ, let's get the simple stuff figured out first before we get off into double slit.
That's what I said. I mean, figure out the sunset, and we'll talk after that.
Yeah, when you finally get it through your head that the Earth is not a fucking pancake, then we can start talking about Einstein.
Yeah. I mean, it's just a way to deflect all the obvious problems, and they think that just because they read something in a popular journal or a YouTube video that kind of distilled down concepts, they get them all botched up. I mean, look at Arwen. I mean, there's a lot of broken glass in his head.
Oh, for sure. I
That's
mean,
a nice way to put it.
These guys can't do trigonometry, and they want to talk about Einstein's field equations. Excuse me? How can that possibly ever work?
Well,
That's right. They were
not
going over
just
something the other day that was
not
sorry, go ahead.
geometry. I stomped on you. I had a lag there. Sorry.
Oh, okay. Yeah, I was watching something with them the other day where they were talking about lateral displacement of relative densities. They had they had salt water versus fresh water separated by an impenetrable barrier. As they lifted it, the salt water pushed under. My bad. The heavier water pushed underneath the other one, and as it raised up, it actually pushed a little bit of the salt water back underneath the lifted barrier. And they're like, oh, look, that proves lateral displacement. It's like, no, it proves that, that you increased weight to one side, so it had to try to shift it back across.
Yeah, it proved gravity.
It was a gravity proof, and they had no understanding of that.
I know it. They prove gravity over and over and over again, and just say, no.
All of the buoyancy experiments.
Every buoyancy experiment proves gravity. You're right.
But I think their problem is they conflate the idea of the explanation of gravity with the description of gravity. Like they say that because there's a problem with the explanation or the theory of gravity, then the law of gravity doesn't exist, which isn't true, obviously. Because
they developed a lot of this comes from Riley. Riley misconstrues words, and having found that Scientific American article by George Musser, and then misunderstanding about the whole gravity is not a force thing, gave Riley an aha moment, and he's been running with that ever since.
Yeah, he's riding that one.
Yeah, he sure
is. He's writing that one in the face of the author coming out and telling him he's wrong.
Yeah.
Is that has he been told that he's wrong by George Musser then?
Yes.
Indirectly, I mean, what was his name? Fight the Flat Earth or something. Interviewed Musser, and Musser basically told him,
Yeah, Colonel Gregg, that's Jay and Truth McCauley.
Yeah, Craig did an interview with Musser, and Musser cleared it up. The thing Quantum or Anthony started out on was that snap the magic wand business.
Exactly.
That's how the whole thing got.
Meaning that it totally destroyed Newtonian mechanics.
Yeah, no, it just made it not magic. That's all it did.
Yeah.
Well, which is actually right. I mean, that's what Einstein did. He finally somebody said, yeah, it's not magic after all. It's not.
The magic wand referred to the fact that gravity was thought to be instantaneous action at a distance.
At a distance.
Now we know it propagates at the speed of light.
Mm-hmm.
I thought.
Yeah, what is
wait,
that?
Wait a minute, just really quickly, George. I thought the magic referred to the fact that Newton couldn't figure out where it came from, so described it as an invisible force.
No, the magic was action at a distance, thinking that it was that the whole concept, quote unquote, action at a distance refers to instantaneous transmission of, the force.
A
Right.
spooky distance.
Yeah,
No,
Spooky action at a distance.
spooky
Yeah.
action
That's
at a distance is something
that's something
entirely
different.
different.
Yeah. Spooky
But,
action at a distance has to do
the,
with duality.
yeah, the magic wand, Dean, was the fact that Newtonian mechanics has no description or allowance for propagation time of gravity. And, in Newton's time, of course, it wasn't, he had no instrumentation or any means to figure out, the propagation speed of gravitation forces and waves. Just like at that time, they had no idea that light traveled at the tremendous velocity that it did. And, so the magic was the fact that in Newtonian mechanics, there's no differentiation between a finite propagation speed of gravity or its effects being felt instantaneously.
Right. Yeah.
What they thought is all of a sudden, if the sun all of a sudden disappeared, the Earth would go flying off. Whereas we know
Instantly.
now it take about 8 minutes for our orbit to
change. Yeah.
to change. Yeah.
Yeah, exactly. Well, that was
Well, if the
and that's what Newton was disturbed about. I mean, he knew there was nothing wrong with his law. He knew that things worked that way. What he also knew is he couldn't explain it. He couldn't explain why it did that. And that caused him, he spent the rest of his life trying to figure out an explanation for it. Of course, it took 200 years for Einstein to come along and say, oh, guess what? There's another dimension we're ignoring here.
You have a
I'm
good one.
still trying to
I gotta walk around.
grasp the concept of a star collapsing in on itself. That's crazy.
Well, one way you can look at it is there's an equilibrium in stars. You have the outward force due to the nuclear furnace of the radiation pushing outward versus the gravitational field trying to pull things inward. And if a star starts burning out of its nuclear fuel, where that outward pressure now is starting to die, gravity takes over and dominates the process, and the star collapses in a rather catastrophic manner.
Yeah, as soon as it starts producing iron, burning iron, that's the end of it.
That's
the
the
end of
easier
it.
way to look at it.
Because it now takes more energy to fuse iron than you get from the reaction.
So what is that? I mean, what does that force represent? Does that represent a singularity?
What force?
When a star collapses?
When a star collapses in on itself, is that a singular? Is that
no?
Well, it becomes a very dense gravitational source, which we call a singularity. What we mean by singularity in mathematics and science is where things, it's like an impulse function. Is you can, you have a rather abrupt change occurring, like a division by zero, trying to divide by zero.
So the other force is still there. It's just not as prevalent as.
Huh?
So the two forces still remain. It's just not.
What two forces?
Well, in a singular, if a star collapses, so a star has gravity and it has an outward force, right?
Well, the pressure, the outward pressure due to the nuclear furnace burning, that portion now dies off at the end of life of the star. So gravity, the mass is still there, so the gravity is still present. Yeah, but it becomes the dominant force after the star starts dying.
Most
So
stars, most stars are not going to become a singularity, though.
Is there a north and south pole on the sun?
Yes, the sun does have a magnetic field about it.
So I mean, they've haven't they like theorized a monopole?
No, magnetic monopoles have never been found, have never been even artificially created. That's one of the fundamental tenets of Maxwell's four equations.
That's right.
Yeah, but hasn't it been like hasn't it been? I know it's never been proven, or
No,
but hasn't
not
it?
even theorized. No theory
No.
predicts a monopole.
What a but what a Maxwell, like what a star like our sun will do when it finally burns out, when it finally starts to fuse iron. It will collapse to what they call a white dwarf. It won't go to a singularity. It'll just become a little thing 20 or 30 miles across with about the same weight or mass that the sun has.
Yeah, we have three things that a star can basically die to. You have, like who says, a white dwarf. You can end up with a neutron star under some conditions, or the thing will nova and blow apart.
Yeah.
Just depends upon how much mass you're starting with.
Right.
As it dies.
I mean, what's this stuff that I've been reading about? Black holes could represent a singularity, but I mean, is that just some crap that somebody thought up, or?
No. But again, you have to define what you mean by singularity. Singularity in this case means you have a very, very small volume in the region of space where there's an extremely strong gravitational field.
I mean, a singular. Yeah, exactly. I mean, a singularity is a monopole.
No, not a monopole.
Well, I mean, it's. I don't
No,
know.
it just happens to be a spot in space where the gravitational forces of attraction are so strong that even light cannot escape once it falls beyond what's called the
event horizon.
The event horizon.
Yeah, but there's this huge there's all this information about how there's this huge attraction. So where is the equivalent of repulsion? I mean, where does
we don't have anything like that. Gravity is always an attractive force. We've never found it to have a repulsive force. You know, unlike electromagnetics, unlike electrostatics, where you have two types of charges, positive and negative, where you can have both attractive and repulsive forces, we do not have an equivalent in material, in matter. It's always attractive.
So I mean that would go back to my my theory of three, the law of three, where there has to be three things. There always has to be one can't exist without two, and two can't exist without three. Basically, there's always a three. There's always like there should be a repulsive force equal to the attractive force somewhere.
Well, that's might be the way you want to think about it, but that's not the way nature works.
Yeah, that's not the reality we live in.
Yeah, I mean, when I first studied electromagnetics as a sophomore in college in electrical engineering, I was always bothered by Maxwell's equations, by the asymmetry in it, because I'm a lover of symmetry. And that's basically what you're talking about, is kind of a symmetry balance. And the laws of electromagnetic do not have this beautiful symmetry. It does in some of the equations. In the time varying equations, there is a symmetry between the magnetic and the electric force. But when talking about what we call the divergence of the field in electrostatic, forces begin, or electric fields begin and end on charge, whereas in gravity, um, the force always begins on matter. Matter is a source, but it doesn't. The fields don't end on anything. That's why the divergence has to be zero on a magnetic field, and you could write an analogous set of equations, an analog to the Maxwell's equations for gravity, and have this same sort of symmetry to some extent. But that's always bothered me, is for the electric field, the divergence of the electric field is equal to the volume charge density in space, whereas the divergence of the magnetic field is zero. And the implication of that is that you cannot have isolated magnetic monopoles. You cannot ever isolate a south pole and a north pole. They always occur in pairs. It's just a consequence of the reality we live in.
I've got a question for Blue. Are you still around, Blue?
Yeah, I'm here.
So I'm going to share my screen. So this is so.
But the thing you'll notice, just one thing, Dean. The
Yeah.
thing you'll notice, Maxwell, if you take a permanent magnet, no matter how you divide that magnet up, you're always going to have closed loops of magnetic fields. That's what we mean by the divergence being zero. You will never, no matter how you divide your magnet up, you will never isolate a south pole or a north pole. You will always have two of them, no matter how small you get down, even to a single domain. There's always a north and a south pole together.
Right. Yeah, I understand that. It's just weird to
Yeah, it is
think.
weird. I mean, that's always bothered me with the equations, but I finally had to accept it because I've looked at all the research. People have tried to artificially create a north or a south pole, and nobody's been able to do it.
Right, you ready,
Can't do
Blue?
it.
You ready,
Yeah,
Blue?
I'm ready. Yeah, what you got?
Right. Okay. So I'm gonna. This is the assertion, and first of all, I want your thoughts on it. So we have a tidal locked moon face, and it appears to have less craters than the other kind of 2/3 coverage than the third that we look at.
Mm-hmm.
Now,
So did you get Rumpus to weigh in on
no,
this?
no, 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 no. Wait a minute, wait a minute. I'm not. Leave that little annoying bastard out of this at the moment. I will do eventually. No, I will do eventually. So,
I've got this as a soundbite now.
so Blue. So my assertion is that is because there are more complications from the Earth side of the moon, speaking relatively to the moon now, than the other sides, and that having two gravitational wells, one at the side, creates more complications and misparameters because it's of a higher magnitude, and not only that, the cone of geometry influence that by the Earth occluding that face of the moon from about 0.5% of coverage. You know, if we're coming at so the blue thing is the Earth, the green thing is the moon. Any meteors coming at this side are going to hit the Earth. End of story. So, what do you think? What do you think about that assertion? First of all, nice.
Well, I don't think I can disagree with it necessarily.
Okay, because the Wikipedia article at this point, which I read, said that the impact frequency is negligible and not the originating reason for the topology and impact craters. It was more to do with back when it was formed and the fact that it has a different kind of surface makeup on one side than the other. But anyway, regardless of that, I said my assertion still stands. Now, to demonstrate it, what I did was I am going to build another more complex model that generates random vectors of meteors within a given volume. But I've set up two gravity wells here. The Earth and the Moon, and the magnitude difference is relative and just you know, it's 9.8 versus, I don't know, 3.4 or whatever, or close enough. And I've got this ring around the outside, of which what I do to demonstrate this is I fire meteors from this outside ring in at the moon directly. Wait a minute, is someone making a really lot of noise?
I'm
Yeah.
sorry.
So what I do is I fire from this outside ring meteors directly at the moon to see what happens, and I make them stick as well. So this is the simulation running.
Dean, a suggestion.
Wait a minute, give me a sec. You can give me a suggestion in the intermission, George. So, now the thing about this is we see how the gravity wells affected those. I know they're not doing 35,000 miles an hour or anything, or relative speeds or anything, but it's more the concept that I was wanting to demonstrate. And we can see that when everything settles and makes impact, there we go, we can see that we have got an area of the moon that is, less touched.
Yeah.
And this is my, this was my theory. Anyway, yes, sorry, George. What were you going to say?
No, go ahead. On the attraction of your impact particles coming from space, is if say they're a long ways away. What I mean by long, let's say 100 distances of the Earth-Moon distance. Okay, that they are going to come in and be attracted to some point between the Earth and the Moon. And it's probably going to be a little bit outside the Earth's atmosphere. I could do the calculation, but if you look at the relative total mass of the Earth and the Moon, with the Moon, let's say with the material equivalent density, with the Moon being about 1/3 the diameter of the Earth, then that cubed is 1/27th. So with equal densities, the Moon would have a density of about 1/30th, or not density, but total mass of the Earth of about 1/30th. I don't remember what the exact ratio is. I could easily look it up. But anyway, what that's going to do is put the center of mass somewhere on the line between the center of the Earth and the center of the Moon, being probably
About where the dots are now, somewhere in there.
my guess would it might be outside the surface of the Earth. It could be maybe inside the Earth. I don't know. I've never done that calculation.
Oh no,
So
but both of these have gravitational fields set up, and they have that relationship. So this is actually
can I ask
working.
Stingray? Can I ask you a question?
Yeah, go for it.
So are these asteroids? Are these just a fixed mass, or are they? Have you went through and changed the mass of the asteroids?
Oh no, just a fixed mass. At the moment, there's no variation in them. You see, so here's the counter argument of which I'm trying to wrap my head around, which is what Rumpus is on about. He says, due to the gravitational fields of the Earth, you would get impacts on the Moon that wouldn't necessarily happen if the Earth wasn't there. So you'd actually get meteors coming in from this direction, where my mouse is going now, that because of the Earth would bend round into the Moon. And he says but he says that cancels out my assertion.
Yeah, we don't know that. I mean, of course, he's pulling that out of his behind, just like everything else. A lot of times,
Oh, another soundbite! I like it.
Yeah, we can conjecture these things. That's what I call flat Earth conjecture. Is a possible proof, a possible theory. This is an Arwin theory. A possible theory with no support. A possible explanation that's probably not based in reality. But the thing is, Dean, again, the argument I use on this is, even irrespective of that, if, say, over 100 million years, if the presence of the Earth produces one less impact on the side of the Moon that's facing the Earth, say one less impact in 10 years, then you're still going to have 10 million more impacts on the back side than the front side. You know,
That's right.
Yeah, I'm just
it
wondering.
doesn't take much of a skew to.
Yeah, no, I know this, George, and I was on about statistically. I'm just exacerbating it here with my contrived example. But it doesn't matter if I start putting variance in. That statistic, the magnitude of it will go down, but it should always exist. The fact that something is, and it could be that when I put all the variables into it, it is just one miss every, it guards it once every 10 years or something. But that's, yeah, like you say, that's millions of misses on that
Yeah,
face.
that's right. And I think that's probably the best answer.
Well, at least
And,
at least I can say that George and Big Blue agree with me, Rumpus. You annoying little shit. Yeah, that's another soundbite.
I agree
there.
with you, and I have no idea what the hell you're talking about.
yeah, I mean, in reality, given the speed those things move at, they've got to be pretty well aimed at either us or the moon to hit in the first place.
Yeah,
I mean,
exactly.
the damn things are going so fast. It's got to be close to online.
Oh, wait a minute.
There's not
Alan Evans in the chat says the Earth Moon System barycenter is under the surface of the Earth, under the planet.
Yeah. Like I said, I've never
be.
done that calculation.
Oh, wow.
It wouldn't surprise me if it was, because when I did the calculation for the barycenter of the Earth and the Sun, it turns out that the center of mass in the Earth-Sun system is only about, I forgot, it's like 20,000 kilometers off the center of the Sun, or 20, let's say about 10,000 miles from the center of the sun, and whereas the sun's radius is 400,000, so it's very close to the center of the sun.
Wow.
With your sun system, so it wouldn't surprise me that the Earth Moon system is similar, but not quite, but off-centered more off.
Yeah,
the
he says it's about 1,000 kilometers down if he remembers correctly.
Yeah, that could be. Yeah.
Hey, if anybody cares, tomorrow is the 28th. Is I believe it's what is it called, the apogee of the moon, where it's closest to Earth.
Oh yeah,
and
nice.
it's so it should be quite a spectacle.
Perigee is closest.
Perigee, yeah. So it should be quite a spectacle if you can see it. I'm always amazed by how large the moon looks when it first comes up. It's just mesmerizing.
But that's a perceptual thing. That's not an actual thing. It might be 13 to 14% bigger than it is at the furthest point away from your observation in its lunar cycle. But the only reason you think it's bigger is you notice it relative to other objects, and you can compare details. So you can have a look at craters and surface detail, and then you see next to a house. And then for the first time, you've had this comparison. Whereas when it's up in the sky by itself, it's not as apparent.
Right.
Yeah, actually.
Yeah, I read something about that too, about refraction or whatever could change the perspective.
I don't think refraction.
It's an optical illusion more than anything.
Yeah. It's your eyes just with detail. The human eye sees detail not too bad. We see color really shit. But
we are, guys. I've got the data here. We're currently the moon is currently 392,712 kilometers right at this moment away, and the perigee on coming up July 5th, the perigee is 363.
What's tomorrow's distance?
Tomorrow?
Yeah.
Let me see. What time tomorrow?
I'm not sure. I didn't get that far into it. I just seen the date.
Well, I'll just advance it 24 hours from now. Okay, let's compare range. The range tomorrow is 387,500 kilometers. And the perigee is 363. So we're still a ways away, about 25,000 kilometers tomorrow. I'll keep advancing here. You guys go ahead, talk. I'll just see how close we get.
Blue, did you remember Earth is seriously flat? I know you probably try and blank out his voice, but do you did you remember when he asked how he kept asking it? Because you all asked him, pick one of your questions, and then he picked a question that it wasn't one of his questions, and he was asking how high would you need to be up floating to see the beautiful blue marble spinning.
I think he's a troll. I think he
no,
knows.
no, I don't think so. I think he's genuine, and I think he's just spaced out, hippified, dope smoking mentalist. But he's amusing. But when he asked, he did ask how high you'd need to be, and obviously that's based on, again, human perception. So there's a variance, but I worked it out. If I was to answer that question, it would be 1,800 kilometers high, would make it so that my peripheral vision, I'd be able to discern massive curvature. And I'd be able to think, looking around, I'd never see it fully in field of view, but I'd be able to say, hey, this is a huge spinning ball.
Yeah. Yeah, certainly you would from that altitude, no doubt about it.
Yeah, but your globaria is
Yeah.
on your blue marble.
Spinning blue marble.
Yeah.
Well, the thing is, it's going to be pretty close on full moon to be near apogee, not perigee, furthest away.
Is the closest is apogee, right?
Closest is perigee.
Oh, it is?
Yeah. The way I remember it is A being first, P being second, it's the opposite. So perigee.
Oh my God, George, that was the worst that's the worst technique ever.
That's how I remember it. Normally you'd think A being first, closest, so I just flip it. So it's perigee is the closest, and apogee is the furthest.
I was misunderstood. I thought apogee was closest.
Apogee's highest point, or the furthest.
Yeah, I see here on June 30th, the the closest approach again is on July 5th. That's the perigee at 364,000 kilometers, basically rounded 364,000 kilometers. And full moon is on July 16th. So you're looking at 364,000 kilometers later. And by that time, the full moon on July 16th, 364,000 kilometers later from the furthest at the apogee. And by that time, the full moon.
Yeah, it's just trippy when that happens. I mean, it visually it looks like it takes up the whole sky.
Yeah, that's what we call the supermoon, is when you have a full moon during perigee.
Right.
Because the moon appears to be almost 10% larger than normal.
And it takes up the whole dang skyline. It's cool. I think it's cool.
Oh, yeah.
I wish we had two moons, like in those movies where they have two moons.
I remember once as a kid during sunset or moonrise on full moon is there had to have been significant refractive effects occurring because the moon was so freaking huge. You could not account for the size of the moonbeam by comparison with terrestrial objects, like that optical illusion accounts for. I mean, this was significantly huger than the half a degree. So there was some. Of course, as a kid, I never realized all these different optical refractive effects and stuff that could be going on. But it was really amazing as to how big this moon was on the horizon. But I mean, that's an aberration. I mean, that is. I've never seen anything like that since. It was a rare atmospheric event.
Aristarchus or whatever.
Aristarchus. Yeah.
Oh, we need to stop Carlos
Oh.
encouraging Pete. Jesus.
Yeah.
Yeah, and that brings to mind a lot of these pictures and photos and stuff that some of these people present. Is you have to ask, can you consistently day after day see the same thing? Just don't bring some rare event or an outlier for me as and claiming that this is proof of your thesis or
That's
your
all they
claim.
want to do, though, George. They just play with anomalies.
Exactly.
Well, did you
Yeah.
see that video? I don't know whether you were both there. The video. Oh God, it shows a Fresnel lens. That
Yeah.
dude. But shortly, so you've got the reality of the situation, and then shortly before he shows you it through the lens, it's got clear what the atmosphere does. It bends light down. So then he puts the lens in front of it to make the sun appear lower. And it's like, no, that's bending light up. You've just had on screen that it bends light down, which would cause things to appear higher. Yet now you've just done the opposite of what you said the atmosphere is. I can't believe no one's pulled him up on that before. Or am I thinking about that wrong? I don't think I am.
I know there's the one, he's got one observation where he takes part of a Fresnel lens. He's got a photograph of a city skyline or something, which is depressed down below the edge of a table. Is that the one you're talking about?
No, I was on about the sun, where
Okay.
what he does is the sun moves away, and obviously it's in parallel lines to the table. Then he, just before doing this, he has the words, the atmosphere, what do we know, and all this kind of stuff. And he's got the atmosphere bends light downwards, and that's it. But then the next thing that you see is he's put this lens on, which has made the sun appear lower when it's going away, which is obviously bending the light up to make that occur that
Yeah,
way. And
that's right.
it's like, how ridiculous can you be? You're saying the atmosphere bends the light down, then to produce this, you're putting a lens there that is bending the light up. That's like the most ridiculous thing I've seen.
Well, it's simply ridiculous that they take a Fresnel lens or a part of a Fresnel lens and stick it on top of a table and somehow or the other say that bears any relationship to reality, which obviously it doesn't, and it couldn't.
Yeah.
That's just a party trick. I mean, what the hell?
Anyway, guys,
might want a couple of bucks. Might want a couple of bucks on a barroom bet using that, but it's not science.
yeah, no, I get it. I just wonder why no one's pointed it out before, because it's clear on the front of his video.
Is that Rob Skiba?
Oh, that's him. Yeah, Rob Skiba. That's it.
Oh yeah, he's famous for fucking around with Fresnel lenses. Yeah.
Yeah, I couldn't remember the name because I don't know people's names because I've not really looked at who the prominent people are. But yeah, no, I just looked at that and I thought, well, I can't remember who was playing it. I think it might have been Chris Berry or something. And it's just like
that's exactly the kind of shit Chris Berry will jump right on top of.
Yeah, but his first statement is true, and then his second action is doing the exact opposite, and that just makes no sense to me whatsoever. It's like that's ridiculous. But anyway, guys, I'm going to call it a night because I'm going to have to go away now. Thank you for the chat, and I shall speak to you all later.
Take care.